All right, you're going to do we're going to do spectrums, light spectrums. Sometimes these are called Kirchhoff's laws. Well, Kirchhoff, he was another German physicist, and he worked with light. And he realized that there are three types of spectrum you can get. If you have an object like our light bulb here, which is a black body, and you take your prism, I have my prism here, but if you take your prism and you let the light come through the prism, here's the prism, and you hit as the light bends through the prism, you get the colors. I'm sure you can't see that on the video, but you get all the colors coming from light. And so if you have a light bulb, you realize, or some kind of black body source, so here's my light bulb. Light coming through that, I run that through my prism here, the light comes out, and it gives me all colors. You get continuous colors, and so we call this a continuous spectrum, or sometimes called a continuum. So any black body gives off a continuous spectrum. Okay? Now, that's not the only type of spectrum you can get. You can take a gas, like in this case a hydrogen gas. And I take that hydrogen gas and I excite it in there. I excite it by, it's just hydrogen gas, there's no filament or anything in there. I put high voltage across it. And what that does is it makes the hydrogen atoms get excited and they run into each other, and once they do that, the electrons bounce up to higher energy. When they release light. Fancy way of saying is, if you can excite the gas, it'll give off light. And that's what it does. This is what hydrogen gas does. So what you can do is you can have a gas, what we call a hot, low density gas. Okay. Or I could say an excited low density gas. It can't be high density gas. If you have a very high density gas with a lot of molecules all right next to each other, it actually acts like a continuous spectrum. But if you have a hot low density gas, light coming from it, you run it through a spectrum, and it comes out, and instead of getting continuous spectrum, you get very distinct colors. Let me show you. And we call this an emission spectrum. And each of these lines are called emission lines. And so each of them gives off specific lines, and those lines are unique to the element. And so, the cool thing about it is every single element has its own pattern of lines. So hydrogen gas, if you look through this through a spectroscope, so you run it through a prism, it would look like this. Most of the time you see three lines, red, blue, this marine thing, and a blue. Hard to see the purple unless you have a really good spectroscope. So you would just see those lines. That's what hydrogen looks like. If we see those three lines anywhere in the universe using our telescopes, we know there's hydrogen gas there. And then the second most common element in the universe is helium. And here's a helium spectrum. This is what helium looks like when you make it glow right here. But this is what you would see is if you look through your spectroscope, you would see those distinctive lines. I have a couple others for you. This is nitrogen, right here, which I don't have a picture of nitrogen there. It has several purple lines, which is why you kind of get that purplish color. And if we do just regular air, like the air you're breathing, if we excite that, it looks like this. Now, it doesn't look too different from the nitrogen because the air you breathe is actually made of 78% nitrogen, about 20% oxygen. And so this is really a combination of nitrogen and oxygen. It has this spectrum in it, plus it would have an oxygen spectrum in it. So each of those spectrums, the most important thing to learn from this is that every single element has its own unique spectral signature. In that every element out there, if we can see the light and we can run it through a prism on a telescope, we can figure out what the object is made of. So that's why stars and galaxies, even though they're millions of light years away, we can tell you what they're made of. We can tell you what elements are contained in it, and we can tell you how much of those elements because of their spectrum. Now there's one other type of spectrum, is if you have a continuous source, like a light bulb or a high density gas, and the light comes through it, but then it runs through a cooler gas, then whatever the light bulb is, then when the light comes through it, light comes out and we get an absorption spectrum. Meaning you get a continuous spectrum, but then there's distinct lines that are missing. Essentially, it's an emission spectrum in reverse. Instead of emitting light at these specific wavelengths, it absorbs them at specific wavelengths. This is called an absorption spectrum. And absorption spectrums are actually what stars put off. Because the stars, the interior of the star is very high density gas. Remember, this is a black body object or a high density gas. Will give off a continuous spectrum. So you have this continuous spectrum inside the star, but then that light has to get out and it has to pass through the cooler outer layers of the star. When it passes through the cooler outer layers, they absorb some of the light and we get an absorption spectrum. So all stars give off absorption spectrums. Gas, excited gas out in the universe, which happens, gives off this emission spectrum. All right? There's not many things that are perfect black bodies, but there are a few that have a very continuous type black body spectrum coming from them. So those are and that's what Kirchhoff realizes, there's only 3 types of spectrums. In fact, Kirchhoff had a buddy named Bunsen. And Bunsen invented the Bunsen burner, which was a way to get a really hot flame in a lab. And so what do you do when you build a hot flame? Well, you start burning everything in sight. And so they would burn it, and then Kirchhoff would look at it through a spectrum, and he realized that all these different elements all had unique spectral signatures. And that's how he determined these Kirchhoff laws. And astronomers use spectrums all the time to figure out what stars are made of, what planets are made of, what the surfaces are, all those kind of things. Chemists use them. They use mass spectrometers. They sent one to Mars, and so when they picked up the soil on Mars, they could analyze it in sight and figure out they just vaporize a little bit of it, and then they look at the light coming from it, and they can tell what's in it. So it works very, very well.